Okay, so we need students to contribute to this changing environment. So how can you contribute? There is the need to embrace the technologies associated with this revolution. As the world is changing, it's changing with technology. So we need to what? Embrace. We need to familiarize ourselves with the changing in the technology. By continuously learning, so we can acquire the necessary skills and competence to adapt and use current new technology into continuous learning.
Please, we beg you, give us.
Please mute your audio. Mute your audio. So we need to keep on learning so that who address ourselves with what? With this changing environment. We need to learn this new technology. And then provide solutions to problems. The third one is provide solutions to problems in our society based on these technologies using resources made available for students. So there are problems in the society and we need to solve them. So we need to provide solutions to the problems in the society. So that the most affluent people in society are those who are able to solve problems. If you're able to solve problems, then you will go far. You are the people the world is looking for, because we need people who can change the world that we are living in. So you need to adapt yourself with this new, this changing world, with this changing technology, so that you can solve problems in the society. That is why we are learning about STEM, to prepare you to become problem solvers. And what tools are we going to use? We are going to use educational robotics tool. So just as you can see on the screen, this is the MBOT STEM educational robotics kit, where you will learn various stuff, building and programming of this robot. Most of you have seen it in your classrooms, and then Mr. Setogo Oyim is holding it in his hand. That's the MBOT building kit. The next one is the VEST robotic building kit. So he will show us the VEST robotics building kit. So this is the VEST robotics. This was built by Spencer and Sheldon. Spencer and Sheldon, if you are available, you can wave your hand for us to see you, for them to know that, yeah, so they built it and you guys can also build it. Most of you have built it before in classes. And then we also have the Lego boost. The Lego boost is here. We also use that. We also use the Android. All right, so this is the Lego boost. Yeah. It's used in Lego.
And I wanted to ask, when we go to Republican, they come there.
Mute your audio. Very good. Very good. Annabelle, can you kindly mute your? That's good. Very good. All right. So we also have the make block. This is the make block. We don't have that kit in the office yet. We also have the Sun Founder Clowning Quadruple Robot. So this is also another tool we are going to use. We also have the Lego Mindstorm. Most of you have seen the Lego Mindstorm. Those in StarTrite, they have seen the Lego Mindstorm. Alpha Beta School, they are using the Lego Mindstorm. So this is the Lego Mindstorm. All right. And then we also have the Tetris robot. It's also another type of kit we are going to use. And then we also have, this is the Lego Mindstorm, the Lego Mindstorm Educational Robotics Kit. So the Lego Mindstorm Educational Robotics Kit is in two types. We have the software and then the hardware. So this is the software, as you can see on the screen. The software comes with a program where we teach you how to program a robot using this software. And then this is the hardware. The hardware are divided into various components. We have the brain, which processes information and send it to the other parts of the robot. We have the motors, which serves as what? The movement part of the robot. It helps the robot to move. And then we also have the sensors, which detect and communicate with what? With the environment. So that is the Lego Mindstorm kit. Yeah, it has the hardware and then the software component. And then we're also going to do a lot of projects. One of the projects we are going to do is the line following project. So as you can see on the screen, this is a line following project. When you come to a competition, we'll give you a mat like this with this line following, and then we'll ask you to program a robot to what? To follow the line. As you can see, this robot here is what? Is following this line. So That is it. And then we also have the color sorting. When I started the class, I said when you are to sort about 20 colors, 2,000 colors, it's going to be tedious, it's going to be boring, and you will need to build a robot to do that. So this is a robot that sorts colors, as you can see here. So this will sort the colors for us. All right, so at this point, I'll pause and then ask if you have any question. If you have any question, just unmute your audio and then ask your question.
I have a question.
Okay.
So will we start a project this week or next week?
Okay. Mr. Setogo, are you available?
Yeah, I am. Yeah,
Okay.
we are going to start various projects. Today, we are just we are into giving an overview of different projects we're going to be working on. But for this week, we are just making sure that we get all the students. We give you an overview, and some of you have already done some of what we are doing. There will be a revision for you, but there will be specific projects as we go along. Starting from this week, it will just be something you can do around your house. Then we migrate from there to another project, and gradually there will be various projects which we hope parents will be able to get some of the kids to your home, and then you can practice that as well. So we're working on all of that, but your question is yes, we'll be working on various projects as we go along.
Thank you very much. So at this point, I will ask if my instructors who are available has any contribution. Mr. Setim and then Roland, if they have any contribution, they can give, and then we'll go ahead.
Okay, so thank you very much, Stephen. This is Roland, and basically, some of you have already done these things in your schools, as Mr. Ayim said. However, we would want you to have a recap of all those things. You need to study thoroughly so that you apply them. And so all the principles you've learned, if we have questions, we're always available. You can send them to us and then we'll try to help. Also, when one of you asks a question, it will be ideal that you try to answer the questions yourself. And so if, for instance, Sheldon asks a question, we would love you, the students, to share your ideas. Try to see if you can solve that problem among yourselves before we, the instructors, will come in. Now, when you do that, it will help you to, as you said, become problem solvers, because that is what we are gradually trying to do. And so we want you to work together. That is more of teaching one another, okay? And it's part of teamwork. So you try to help one another and then solve problems together, and then we are also here to help you. So I think that's what I would have to say, Stephen.
Okay, Stephen, go ahead. Yeah, Stephen, go ahead.
Sorry, I had a problem with my network. Okay. So let's continue. So hope all of you can see my screen.
No, you have to share your screen again.
All right.
Or you want me to share my screen?
Yeah, share your screen. I'm having a problem. I don't know what is happening. Okay, I think I'm.
Are you okay? Okay.
No.
Right, so sorry, I had a. Hope you can see my screen now.
Yeah.
Yes.
Okay, very good. So now we've learned about robots, we've learned about the types of robots, and we've learned about. Please mute your audio. Mute your
Annabelle,
audio.
it's Annabelle. Go ahead.
Good,
Go
thank you.
ahead.
All right, so we are going to learn about how do robots work. How do robots work? How do robots work? So robots are just like simple machines made of many different parts that can run automatically without a program. So just as Mr. said, can you show us the first robotic kit? The first robot. Very good. So this robot you can see, you'll see it as very complex, but it's not complex. It was just made of different parts that can run automatically with a program. So different types of simple machines came together to form this robot. In this robot, we have what? We have the wheel and axle, we have the pulley system, and we also have what? We also have the screw, which is also there. So there are different types of simple machines that came together to form this robot. So robots are just simple machines. So first of all, we need to understand what simple machines are. So to understand how robots works, to understand how robots are built, we must first understand the parts of machines that work automatically, and they are called simple machines. Without a program, robots are just many different simple machines all together. So robots are just but simple machines being put together. That brings us to the question, and I'll have to ask the question, what do you understand by the word simple machine?
Simple machine.
Yes.
It is a robot. It is a machine that you can build easily.
Okay, that's very good. You have done well. And what do you understand by the word simple machine?
A simple machine is a machine that makes things easier to move and to get things.
Okay, so that's very good. I'll take the last contribution. What do you understand by the word simple machine?
A simple machine is machines that make work or construction easy.
Simple machine is a machine that is.
That's very good. So let's continue. All right, so now let's read the definition of a simple machine. I will ask Sheldon to read it for us.
Simple machines at schools used to make work inside when defined as a force acting on an object movement across a distance. Pushing, pulling, and lifting are common forms of work. A force is any push or pull that causes an object to change position, into brackets, movement, direction, or shape.
Very good. Thank you very much. So simple machines are just what tools used to make work what easier. So can you think of your home, any tool that you use in your home that helps you to make work easy?
A
You have any-
microwave.
A microwave, okay. What does a microwave do?
A microwave, like if your food, for example, if your food is like cold and you want to heat it, you just go and put in a microwave and to do it the work easier for you.
Okay, so microwave comprises of different types of simple machine that has been put together. That's good. Any other? Can you think of
Yes,
any tool?
please, yes. Ex- example is a pulley.
A mobile phone.
That's good. What does pulley help you to do in your home?
It help, for example, if we want to get something to the top of the roof, we simply put up a pulley. Then we put, for example, if something got spoiled up the roof, we'll use a pulley to carry the things used to fix it to the top so that someone too can climb to get it done.
That's very good, Yofi. You've done well. All right. So in your homes, another example is scissors. How many of you have scissors in your home?
I do.
Very good. What do you use the scissors for?
I do.
It is used to cut papers or any other things.
Very good. So all these are what examples of simple machines. It makes work easy. All right. So the tools used to make work easier. So what is a simple machine?
A simple machine are tools used to make work easier.
That's very good. So in science, we've learned about work. Work is defined as what? As force acting on an object to move it across a distance. So for every simple machine to be able to perform a task, work needs to be what? To be done. Okay? Work needs to be done. And work is defined as what? A force acting on an object to move it across what? A distance. Okay, so this is my mobile phone. I want to make call. So I need to raise my mobile phone to what? To my ear level to make call. In that process, a work is what? Is done. I use a force to what? To raise what? The mobile phone, and the mobile phone move across what? A distance. That is work. If you have a table in your home, you don't want to study at that particular place, you want to study at a different place. So therefore you push the table to a different direction. So that means work is what? Is done here. Because an object has moved across what? A distance. And that's using what? Force. And we define force as what? As a push or what? Pull that causes an object to what? To change its what? Position. So just as Yofi said, you have a pulley and you want to raise a heavy load. So you pull you pull the thread that connects the load, and the load will be what? Will be moving upwards. Whilst you are pulling the load, you are what? Applying what? Force. And whilst the object is moving across what? A distance. And that makes what? That defines work when the force moves an object across a distance. So at this time, I'll ask you, Yofi, can you define what a work is?
Well,
Yes, if he's not available. Okay, he's
Yeah,
available now.
work is defined as a force acting on an object, or it's used to. It's like you have to use your own body to do what you have to what you
Okay,
want to do,
that's
or
very good.
any object.
Okay, any other contribution? Who can define work? What is work?
Jason, I saw Jason. I think Jason's on this call, right?
Jason, was yeah. Listen, can you define work? What is work?
Miguel, where are you?
Work is defined as a force acting on an object.
Very good, that's good. So whenever a force acts on an object and the object moves according to plans, there is a work. Okay. All right. And then the next work we talk about is force. Whenever there is a push or a pull, there is what? A force there. And that push or pull causes an object to what? To change its what? Position. So at this point, do you have any questions? If you have a question, unmute your audio and then ask your question.
Say. Say.
Okay.
Say.
Is that Annabelle?
Say, please. Say, please. I didn't get there.
Yes, I'm listening.
Say, please. I didn't get the first principle of this one. I didn't get the first principle, the color sorting and the rest. I didn't get the first one.
Okay, all right. So let me quickly take you to the color sorting. All right, so the color sorting, we were talking about robots. We said that robots are what? Are machines that does work that are too boring, too dangerous, and difficult to perform, okay? All right. Imagine you want to sort about 10,000 colors.
Okay.
You have about 10,000 colors that you want to sort. It's not going to be boring for you.
Okay.
It will be boring. So you want to, what, to program a robot to what? To do that. So you build this robot. This is a color sorter robot. And then you pour in what? The colors. And then you program the robot to what? To sort the colors for you. And the robot will what? Will sort the colors for you. You understand? Very good. So in that case, the robot has what?
No.
The
No,
robot
I'm not
has
sure.
what? To make your work
It's not Bountiful
faster and
technology.
more convenient. Annabelle, is your question answered?
There is something with the voice.
It is
Hello,
Okay.
hello, Brother Steven.
If the internet,
Hello, Brother Steven.
maybe
Yes,
you
I'm
go out.
listening.
Okay, so what I want to know also about the sorting of the colors.
Okay, I'm going.
What of if the what of if the colors are big enough? How are you going to bring out the robot?
Please, those of you who are not talking should mute your audio so that I can listen to the question. Please come again.
Okay, so I was asking now with the color sorting. Okay, if the colors that you are sorting are bigger enough, how is the robot going to be built?
Okay, so with the color sorting, all that we need to do is what? Is put the colors inside. So maybe you can fetch a particular quantity and you put them inside. And then the robot will sort them. So as this place gets filled, you have to what? Remove them. Or you can actually build this place to be what? To be big. To be big enough to what? To be able to arrange all the red colors here, to arrange all the yellow colors here, to arrange all the blue colors here, and all other colors. So depending on the quantity you want to sort, you have to build a robot big enough to do that.
Thank you.
All right. Thank you very much for everything. Okay, so at this point, I will ask and Roland if they have any contribution to give on the simple machine, the definition of simple machine we've just discussed here.
Okay, so I'll a little on the simple machine, and then I would also the question that was asked earlier on. I'll also talk briefly about that. That's regarding the color sorting. So for simple machines, we said that they are things that help to make work easy for us. Okay, we talked about the scissors. Another one is a hammer. Okay, it also helps to make things easy for us. Just the simple things we use at home. Okay, that will help us to make something easy. For instance, if let's say you have a barrel of say oil, or let's say a gallon of oil. Okay, and maybe mommy is not at home, and you can't raise a gallon by yourself. Maybe you're supposed to lift it up the stairs, and you can't do that. What you do is you try to get a wood or a plywood on the stairs, so it becomes an inclined plane. Okay, it slides down the stairs, and then all you have to do is push the gallon of oil on top of the wood, and then try to be rolling it gradually until what you're able to push it up the staircase. And so that is an example of simple work, okay, or a simple machine. You putting that wood there to help you push the oil up is an example of a simple work. And so as Brother Steven said, there are so many types of simple works. We'll be talking about them later on. Also, regarding the question that was asked earlier on about the color sorting. Now, before you build a robot to solve a problem, it means that you must first identify what the problem is. Okay? Because you can't just create something that can't solve anything. You are building the robot because you have identified a problem, and so you are designing the robot in order to solve that problem. And so if your colors that you are going to sort are big, it means that you've identified your problem. You know that what you are going to sort is big. And so you are going to design your robot in such a way that it can take care of the size of the colors that you are dealing with. For this one, you saw that they were small, and so it was built to suit the colors, the size of the colors that were used. And so in like manner, if your colors are big, you have to create something bigger, or maybe one that is unanimous or multi-purpose, so that regardless the size, you can always sort them out. And so it depends on you, but the most important thing is to always identify your problem before you go ahead with building your We've gone through the steps, that is robotics. We've gone through them, the planning, the designing, the construction, and all that. And so there are steps. And so we shouldn't forget those things. We must always remember to apply them in robotics. All right, so that's what I'll have to say, Stephen.
All right, so thank you very much. So now we go to the types of simple machines. So just as we have said, we have wheel and axle. We also have the inclined plane. We also have the wedge. We have the lever. We have the pulley, and we have the screw. So there are 6 types of simple machine: wheel and axle, inclined plane, wedge, lever, pulley, and what? And screw. So what are the 6 types of simple machines?
Screw.
Good.
Like to say one.
Wedge.
Okay.
Wheel and axle.
Lever.
Very good.
Inclined plane.
Okay, very good. So these are the 6 types of simple machine. So let's take them one by one and let's see what each of them does. So the first one we'll talk about is the inclined plane. So have you seen this old man? This old man wants to park his blocks. He wants to park them on this wall. So he wants an easier and more convenient way to do that. He's slanted up that will be able to work on the board to put the load here. So that is an inclined plane. Inclined plane is a flat surface that is slanted or inclined so that it can help move objects across the distance. So this is what the ramp is a common example of an inclined plane. It helps you to move an object across a distance. Very good. And the next one is what? Is a wheel and axle. As you can see, if you go to the beach and you are very tired, you just sleep on this one and then someone will just push you. Because it has what? Because it has wheel and the wheels are connected and axle, it makes what? Movement possible. So wheel and axle makes what? Movement what? So it makes work by moving objects across the distance. The wheel turns the axle, causing what? The wheel. When the tether is, you can see the wheel, and this is also another wheel. And the wheels are connected together with what? With an axle. Okay.
Please,
So
somebody's
when the wheels turn,
audio
the axle
is on. We can't hear. Please, the sound is bad.
We can't hear you all.
Yes.
No, your audio is on.
Oh, please, I'm having a problem identifying the axle.
Okay, so this is the axle, where the pointer is. My white pointer, have you seen?
Yes.
Yes.
This one.
Okay.
This is the axle, okay? And then this is the wheel, okay? So we have one wheel here, and we have another wheel here. So the wheels are connected together with what? With an axle. You understand? Just
Okay.
Okay. Yes.
Just like the robot, Mr. Sex showed that. You see that the robot has types, okay? And the types are connected together with what? With the shaft. So at this point, the shaft is also known as what? The axle. Okay. So once the wheel turn, axle also what? Turn. That makes what? Movement to be what? To be possible. So all this while you have been building the robot, but you don't know that the wheel is what? Is a type of what? Of a simple machine, which is known as what? Wheel and what? And axle. Okay. The next one we'll talk about it. Okay. I think we Mr. Sex, are you available with us?
Yeah. We have few minutes. We have to. This is almost a concluding part of this.
Yes. So I think for today we have to pause here, and then we'll take few. We'll ask you a few questions, and then you will answer. And just 2 questions. I want 2 people to tell us what they have learned today. Just 2 people to tell us what they have learned today.
Still, the people are listening.
Is Annabelle available?
No, she's not.
Okay, yes. Sheldon, what have you learned today?
I learned about simple machines and what robots are.
Okay. So can you give me one example of a simple machine?
Scissors.
Okay, that's very good. Any other person?
I learned that.
Yes, Spencer. Talk when you finish. Talkers will continue.
Okay. I learned that simple machines I learned about examples of simple machines and what simple machines are.
Okay, that's very good. And then Dorcas, give us the last contribution. What have you learned today?
No.
We've learned about simple machines, liver.
Okay, that's very good. So your assignment is, we'll post the assignment on the platform. You identify the types of simple machines we have. That will be our next lesson. So I'll give the rest of time to Mr. Setogo and him to give us the concluding remarks.
Okay, thank you.
Yeah, thank you so much. We thank all the parents that made it possible for their awards to be on this program. We will continue this week, every week, but starting from next week, be twice a week. We'll be meeting twice a week for 40 minutes. And most of the times we'll be sending you projects that you will work with your kids at home, and we put the students in teams that they can coordinate. The parents can help them coordinate and work on those projects. We are so much excited to have you, and we continue to reach out to you in your homes as we stay home because of this virus, and we are praying that the virus will go away and we can be together again. But without anything to do, you keep busy, keep yourself safe, follow all the instructions mommy and daddy are asking you to do at home, and make sure you get yourself engaged. Identify most of the simple machines that we talk about today at home. One of the challenge I want to give you today is go out there, in the home, look for those simple machines, draw them and color it. We will showcase 4 students next week who were able to do a very nice job by drawing their simple machine. And there are some videos also we'll send you to watch at home to see how the simple machines are in action. Thank you. Have a wonderful day. We love you all, and keep doing the right thing. And then we pray to see you tomorrow. Bye-bye.
Okay, bye-bye.
Bountiful Technologies, we make technologies.
We make technologies work.
Bountiful Technologies.
We make technologies work.
Thank you.
Bye-bye.
We'll send the slides as well. The slides will be on the learning page, so your parents can go and download that for you. Our contacts are all there, and the WhatsApp page